This is the example from the lecture notes. The question says how to test that one vector is parallel to the other two, which is effectively this line. This is the encoding for the sentence, vector x being parallel to the combination of A and B. And in the example on page 18, you're given these two vectors. Here's a vector x. That's the components of four-dimensional vector x. Here's the components of the four-dimensional vector A. And here, the components of the four-dimensional vector B. The tutorial question 32 is very similar to what I'm going to do right now. It is stated a little bit differently, but effectively, it's similar tests there. You have to test that one vector is parallel to the span of the other two. So when we test for something like this, if you remember what the span is, we need to see that if we can find two numbers, we need to see that if we can find two numbers, lambda and mu, such that x is a linear combination of my A and B with these two numbers. And effectively, this is another system of linear equations, because if you replace your x with the components here, A with the components here, and B with the components here, that will be a system of four equations with two unknowns. Here's a system. Well, actually, that's a replacement. Here's the vector A, here's the vector B, and that's the vector x. I just replace my A with the components, B with the components, and A and X with the components. If you equate now in a per component way, is the equations in terms of lambda and mu. Four equations, two unknowns. The interesting thing about this question, we don't need to find the lambda and mu, by the way. I mean, the question itself doesn't require that. The question just requires to see whether we have them or we don't have them. The actual values is irrelevant, because if we have them, my vector will be parallel to A and B. If we don't have them, my vector will not be parallel to A and B. The actual values, we don't care about them. And that's a perfect case where the row echelon form is effective. Because if I extract the augmented matrix of this system, is the extraction. It's the first row, 1 for lambda, 0 for mu, 3 right-hand side. That's the second row, -2, 4, 0. Third row, 3, 1, and 5. And the last one, 2, 2, and number 6. If I take this to the row echelon form, and this time I'll tell you, this is the solution, problem 6, solution helper in a solution helper. I have the details for this conversion. If you won't be able to reconstruct those details, you can open the file I just showed you today, and you can find those details there. So if I take this to the row echelon form, by looking at this row echelon form, the answer is in me. What's the answer? Is my vector x parallel to AB, or is it not? No. And how would you support that with the evidence? Because we have a pivot on the right-hand side. Here it is. And that's all there is to it.